Hello students, in this video we will be learning about introduction. So what is the communication? I am giving the very basic definition in my point of view. Communication is nothing but information interchange, or you can call information exchange. What is the information? We'll discuss. Of course, I'm taking a class, that is called some information. You are talking, that is called some type of information. You are listening a song, that is called one type of information. You are seeing a movie, that is one information. So what is the basic definition for information? I will give you later. But what we are going to be study in communication system is how effectively we are sending the information between 2 points. What is the meaning of effectiveness? You need to understand that. Let me take a very simple example. Today I am taking the class in Hyderabad. For example, tomorrow I have the class in Pune. So to take the class tomorrow in Pune, what I have to do? I have to take my luggage. I have to come from Hyderabad to Pune and I have to take the class there. For example, to going to Pune, only there are 2 options are available. First one is I can go by flight. Second option is I can go by walk. These are the 2 options we have. Then what is the effective way to go to Pune for taking the class? Yes, please tell me. Yes, obviously by flight. Means here also we are using our communication system, means we are sending our information via flight. Not using means we are sending our information via walk. That much of effective difference is there by using the techniques of communication system, and we are using that in a better manner to sending our information. For example, if you see GSM mobiles, what is the technique we are using? Gaussian minimum shift keying we are using. What is this minimum shift keying? We will understand in the digital communication. Like you might be heard about amplitude shift keying, frequency shift keying, phase shift keying, like these are the variant. Now we are using Gaussian minimum shift keying in GSM mobiles. That is the 2017, I think, 1 mark question from the communication system. I think all of you understand what we are doing. We are sending our information in effective manner. So what is the technique or what is the tool we are having in our communication system? Yes, in communication system, what we are studying? Can you please recall the topic names? So starting topic, modulation, amplitude modulation, frequency modulation, phase modulation. Same variants will come in the digital. So we are having the tool of modulation. So by using the modulation tool, we are sending our information in an effective manner. That we are learning or that we are doing in our subject. So what is the modulation? What is amplitude modulation? Further it will come, sir. Before that, come to the point of information. What is called information? I can say, are you getting my point? What is called information? In the previously I told that any quantity, general definition I am giving, any quantity having some valid thing in that, or any quantity what we want to transfer between 2 places. For example, you have to send some courier services from Hyderabad to Pune. So here that courier is nothing but the information. So information is nothing but what we are giving to the transmitter for transmission purpose. That may be anything. So anything we are giving to the transmitter for transmission purpose, that is called the information. Basically in our communication system, we are discussing about the 2 types of informations. One is called analog information. Another is called digital information. You might be studied in the signals. What is called analog signal? What is called digital signal? Are you getting my point? And another version also you might be heard about there. Continuous time and discrete time. I am not now discussing about continuous time and discrete time. I am discussing about analog and digital. This analog and digital, how we are classifying. For example, let's take, for example, I am taking one signal here. Plus 5 volts to minus 5 volts. A sine wave I taken. Here one more signal I taken. A square waveform I taken. This is also 5 to minus 5. For example, two signals I taken. Can you please tell me, out of these two signals, how many of them are analog? How many of them are digital? Are both are analog or both are digital? Please tell me. I written two signals on the board. So, in that, how many of them are analog? How many of them are digital? Are both are analog or both are digital? Yes, both are analog. Okay. Any other doubt? Yes. One is analog. Obviously, another one is digital. I am not discussing about continuous time and discrete time. Continuous time and discrete time we are discussed based on the time axis. If it is defined for all values of time, continuous time. Defined only for integer values of time, integer values on the time axis, discrete time. But here, analog and digital is classified based on the amplitude levels. What is the amplitude levels meaning here? Both range is from minus 5 to plus 5 volts only. Between minus 5 to plus 5, how many possibilities are there? Regarding my point, infinite possibilities are there. So if you take this signal, it is starting from 0, 0.1, 0.2, 1, 2, 3, 4, 5 and so up to minus 5. The meaning is, this signal is taking all possible values between in this range. But if you see the signal, it is taking 5 or minus 5. 5 or minus 5. Means, out of infinite possibilities, it is taking only two possibilities. That is called digital. Not only two, finite number. So what the meaning for analog and digital signal? If the signal amplitude is allowed to assume all possible values in its dynamic range, called analog. Finite possibilities, digital. So we are discussing, we are also having two parts. Analog communication, digital communication. Are you getting my point or not? Clear? Yeah. Let me discuss about the analog information. Coming to the analog information, I already given the definition. What is the definition? The amplitude is allowed, or signal amplitude is allowed to assume all possibilities in its total dynamic range, called analog information. Means it is having the two levels. Vmax, for example, V minimum if you take, it can take any value between them. Digital means only two values I told. Yeah. Let me take some examples. For example, voice signal. Like audio signal. Like video signal. Now you might be studied about, there are some frequency ranges for voice, audio, video. What is the difference between voice and audio? Let's take a simple example. Voice means pure voice only. Audio means you can take the example of a song. So in the song we are having voice plus sounds from the music instruments. So what is the frequency range of voice? Voice frequency range we are taking from 300 to 3.4 kilo. Maybe some books 3.5, 3.6, that is not a matter. Why I am taking this range only? Because if you take any human being in the world, maybe male or female, the total information, the total important or most of the Most of the information will be existed in this frequency range only. For your understanding, I will tell you one best example. Suppose you are talking with your friend. So, in two ways, one is you are talking over the phone. Second is you are talking with your friend by sitting side by side. These are two. Same, you are talking with the same friend in two ways. One is over the phone, another one is you are talking by sitting side by side. In this example, your friend is saying, you also said. Now, your friend voice will be same in the both situations. Your friend voice is same in both situations or not? Tell me. Are you getting my point or not? Your friend voice will be same or different? Obviously, you might experience that different. If not, you can check also. Why we are getting different voice over the phone? You can think about it. Yes, why we are getting different voice? Someone saying atmosphere, okay. Noise, okay. Another one, disturbance in the medium, okay. But let me take the system or the environment is ideal, even though we'll experience the same. Why? Why you are experiencing like that? Because let's see. Here I told this is the most of the information only. When you are talking, you are also get 5 kilohertz, 7 kilohertz, some random values I'm writing, not is the exact. Some 8K. These frequency components also will come whenever we are talking. So that's why when your friend sitting side by side, he can also experience these frequencies. Why? Because human ear having the capability of listening up to 20 kilohertz. Are you getting my point or not? But if you are talking over the phone, they are limiting only up to here. Even though they limit up to here, our purpose is done. Because of limiting up to here, your feeling voice is different. Why, sir? Why they are limiting up to here? Why they are not taking? One point is our purpose is done. Most of the information is going on. And why they are limiting is because the important parameter in the communication system is students' bandwidth. Here a band of frequencies you are sending, that is called bandwidth. So if the bandwidth is increasing, cost is increasing. One of the most important parameter in communication system, bandwidth. Second parameter is power requirement. If bandwidth is increasing, meaning is cost is increasing. Increasing the cost is not a desirable factor. You might be some long back, 15 years back, I think you might be seen 2G spectrum scam. Means in UPA government. Means they are giving the spectrum for less cost. That scam itself is 1 lakh crores. Are you understand my point or not? So spectrum means bandwidth is very, very, very important parameter. Are you getting my point or not? Yeah. You understand the difference? Coming to the audio, what is the audio frequency range or audible range? 20 to 20 kilohertz. Here, this 20 to 20 kilohertz is our audible range. This we can break into three parts, means what is there in the music, I will tell you. This 22, are you getting my point or not? 300 is called low frequencies. These low frequencies are called, students, bass frequencies. How we are generating these bass frequencies? By using skin instruments. Skin instruments. What are the skin instruments? Coming to the skin instruments, drums, tabla, like that. What is this 300 to 3.4 is nothing but I already told voice frequency. This 3.4 to 20K is called high frequencies. These are called treble frequencies. How we are generating these? By using the string instruments. Are you getting my point? Coming to the string instruments, violin, guitar, cello, like that. If you see any kacheri program, of course in Hyderabad, like in Ravindra Bharati, if you observe there, in the main stage, what will be there is, the main singer will be there. One side, this skin instrument persons will be there. Another side, string instrument persons will be there. All those three people are performing in some meaningful manner. So you are getting some meaningful things is coming to your ear, because voice is nothing but pressure vibrations in the air. Those vibrations are reaching your ear and you are feeling some pleasant thing. You got my point or not? Next, coming to the video signal. Listen, this question is important. Possibility is there coming for objective question in the engineering service examination. Chances are less in GATE because theory question. Video frequencies are from 0 to 4.5 megahertz. Mega. 0 means it is also having DC component also. Are you getting my point? Here, what is the objective question is, where we are video signal means, if you take the commercial television. In TV, for sending a video signal, what modulation scheme we are using? That's a question. In the previously in the GATE also asked. Still chances are there in the engineering service examinations also. Getting my point? In TV, what is the modulation scheme we are using for transmission of video is, remember, further also it will come, I'm saying here, VSBSC. If VSBSC is not there in the option, you have to go for amplitude modulation, because VSBSC is one of the variant of AM. So for video, VSBSC meaning vestigial sideband suppressed carrier modulation. Are you getting my point or not? Now, this is for video. So audio, wherever if you listen the word audio signal, best thing is FM. This is for video. So finally, what are the modulation schemes we are using in TV? We are using what are the modulation schemes in TV? For video, VSBSC, audio, tell me, FM. Further also about the VSBSC we'll discuss, but as a point came, so I discussed it here. Clear? This is about the audio, or the analog information. Clear? Now we are discussing about the digital information. What is the definition I given for digital information or digital signal? The signal is taking only finite possibilities in its total dynamic range is called a digital. Examples are Morse code, LAN, data from the digital computers, like that. What is a Morse code? Maybe diploma students will know about this. They are having one question also coming. Tell diploma students. What is a Morse code? This Morse code we are using in the telegraphy. Of course, now telegraph services are not there. I think in the last 5 years they closed it. So what is that Morse code? We are having only two symbols, marking and spacing. This comma is not there. This separation I given. So marking and spacing, these are the only two symbols. What is a modulation scheme? They are used also in telegraphy, frequency shift keying. So only two means whatever may be the letter, if you want to, only they are representing with these two symbols only, like different combinations are there. The most frequent letter, if you take E letter, they are showing with this marking. like A having mark space, or like combinations are there. So here, why this is digital? It is having only two possibilities, whatever maybe only two. So that's why I told finite possibilities. Are you getting my point or not? So finite possibilities digital, all analog. Clear? Yeah, for example, if you take any word, for example, I am pronouncing as a communication system. Means what I am doing is, I am taking the mic is connected to the CRO, and I am pronouncing the word communication system. According to that, some waveform will be like this, something will be displayed on the CRO. If you see that waveform, is it looking like a analog or digital? Obviously analog. Now if you see this one, it is sinusoidal or non-sinusoidal? You understand my point or not? If you see it, that is a sinusoidal or non-sinusoidal? Obviously non-sinusoidal. Means here analog signal can be classified into two types. One is sinusoidal, another one is non-sinusoidal. What is the fundamental difference, or what is the difference between sinusoidal and non-sinusoidal signal? Yes, please tell me. The basic difference between sinusoidal and non-sinusoidal. Yes, someone is saying that. Sinusoidal signal means it is having a single frequency component. For example, if you take any sine wave, it is having a single frequency component, maybe sine or cos. But if you take any non-sinusoidal signals, for example, square waveform or a sawtooth, like if you see the Fourier analysis, you will find a multiple number of frequency components. Means non-sinusoidal signals are having multiple frequency components along with the fundamental frequency component. Are you getting my point or not? What are the examples for sinusoidal signal? You might be studied in the 12th standard in physics. Simple harmonic motion is an example of a sinusoidal signal. Like tuning fork. If you hit the tuning fork, this sound will come. Means that is nothing but a sinusoidal signal. Are you getting my point or not? Means if you see the signal, if I break into parts each and every tone, if I break each and every tone, that is nothing but a sinusoidal. Means non-sinusoidal signal is a combination of sinusoidal signals. Writing the non-sinusoidal signal information as a sum of sinusoidal itself is called Fourier analysis. Are you understand my point or not? In the Fourier series, what we are doing in the trigonometric Fourier series, the periodic signal information we are writing as a sum of sinusoids. Why we are writing? To make the analysis simple. Are you getting my point or not? Now, sinusoidal signal having single frequency component means, for example, if you take 1 kHz sine wave, it is having 1 kHz frequency component only. Like if you take 1 kHz square waveform, it is having 1, 3, 5, 7, like and so on. Why I am pronouncing odd is because it is an even harmonic. Only odd harmonics are existed, sorry. So that's why I am saying 1, 3, 5 like that. Because of the symmetrical properties you see in the Fourier series. So the general form of a non-sinusoidal signal is, it is having DC component plus fundamental frequency component plus even harmonics plus odd harmonics. Based on the nature of a signal, some of them are having even, some of them are having odd harmonics, some of them are having DC component, some of them are having not. Are you understand my point? Clear? What is the most of the information available will be analog, non-sinusoidal. A non-sinusoidal signal information we are writing as a sum of sinusoid. That is a Fourier analysis. Clear? Now we are going to discuss about the general block diagram of a communication system. If I take a simple block diagram, what is having communication system is, we are having transmitter, and the middle one is a channel, and we are having receiver. This is the general block diagram of a communication system. And here in the channel, noise is going to be add. So there is an objective question also asking, in communication system, where is the most of the noise is added? It's general question in ESET and engineering service examination. Most of the noise in communication system is going to be added in the channel. This is called a channel. Got my point? Sir, what is the transmitter, sir? Transmitter will process our information in such a manner that now that is suitable for transmitting through channel. What is the channel, sir? Where is our information is passing? That is called channel. Receiver will collect the information from the channel and giving back our original signal. What is the noise, sir? Noise is an unwanted signal which is going to disturb our wanted signal. So, we can also give the definition for communication system is nothing but the fight or the war against the channel noise. How effectively you are fighting about the noise, then SNR value will be good at the input of a receiver. SNR meaning is signal to noise ratio. If SNR is good, then final quality of a reconstructed signal will be good. One of the important parameter in communication system, SNR also. Previously I told bandwidth, now SNR also, signal to noise ratio. Are you getting my point? That SNR value depending upon how effectively you are working on the noise. Clear? Are you getting my point? Now, what is the blocks we are having in transmitter? Are you getting my point? For example, let's take a public speech. If we take a public speech, there is a politician will be there, he is a speaker. So after the politician, what is the next thing you are seeing? There will be some mouth or mic. Are you getting my point? So here the politician is the source of information. So the first block, source of information. The next thing is we are having mic. Mic is nothing but a transducer. What is the mic will do? Mic will convert this voice. Voice means what I told, pressure vibrations in the air. Depending upon the pressure generated in the vocal cords of the politician, there will be some pressure vibrations will come. So mic will convert these pressure vibrations means voice into suitable electrical signal. So mic will convert voice into electrical. Sir, why we are converting voice into electrical, sir? Directly we can transmit now. Are you getting my point? Here, why we are converting all these physical variable into electrical signal? Because these physical variables, if you transfer any distance, practically it is impossible to reproduce the same. But if you transmit as electrical signals, then how much is the distance you can transmit? There you can get back the same electrical signal back. Are you getting my point or not? So we are converting all physical variables into electrical signals and we are working. After the mic, if you see in public speeches, what will be there? That is connected to the amplifier boxes. Why? Because if you take a public speech, there are number of loudspeakers will be there. So it is not possible for this weak electrical signal to drive on all loudspeakers. So we are giving to the amplifier. Amplifier will amplify that electrical signal to a suitable level, then it can drive all the loudspeakers. Here, that loudspeaker is nothing but a receiver. And loudspeaker, what it will do? For the loudspeaker, we are giving the electrical signal. It is converted into same physical form, that is voice, but with the bigger sound, then it can be audible to the lot of people. That is a general thing if you take in the wide communication system. Same in the wide communication system also, if you want to go for multiplexing, means if you want to transmit number of channels, then obviously we are going for multiplexing. There we are including another block called modulator. If you are not using the modulator, then multiplexing is not possible. Why, sir? Why multiplexing is not possible without modulation? Just simple example. Now you are listening the communication class. Same timing, same. You are also listening the signals class. Like same time you are also listening the mathematics class. 3 subjects you are listening simultaneously. Then which subject you will understand? Obviously nothing. Because the mixing of 3 you will get. Like you can listen 2 or 3 FM stations directly. Then you will get a mixing of that. So that's why there should be a proper separation. So for FM also there is a proper guard band will be there. So between each and every channel, to make that one, modulation is needed. About this multiplexing concept, we will discuss clearly in FDM. Just overall I am saying here. So what is the additional block will come in the in the receiver side? Demodulator. This is about the wired communication. For example, if you are going for wireless, after the modulator, there will be a transmitting antenna. In the receiver side, there will be a receiving antenna. Are you getting my point or not? Like FM, if you take the example, at the FM station, they are radiating the signal. In the receiver, your mobile, you are connecting the headphones. Headphones are nothing but receiving antenna. This is the general block diagram of communication system, wired and wireless. Are you getting my point? Now, based on the flow of information from transmitter to receiver, there are 3 types of systems we can say. The first one is simplex. Second one is half duplex. Third one is full duplex. Sir, what basis we are classifying this? Based on the information flow between transmitter and receiver, 3 types of systems are there: simplex, half duplex, full duplex. What is simplex system, sir? I will tell you example you can recall. Radio transmission, TV transmitter is simplest. That means the simplex systems. Means the flow of information only from transmitter to receiver, unidirectional, not from receiver to transmitter. Examples are, I already given, radio and TV. What they are transmitting, we will able to see that, but we cannot speak here, that cannot go there. What is half duplexer? In half duplex also the flow of information is unidirectional only, but transmitter and receiver can be interchangeable. Means information can flow from transmitter to receiver or receiver to transmitter, but at any time only one. Best example are walkie-talkie. What is a full duplex? Now you will get the clarity over that. What is a full duplex? Full duplex means the information flow is bidirectional from transmitter to receiver, receiver to transmitter at any time. Are you getting my point? Example is telephonic. This classification based on the transmission, based on the information flow between transmitter and the receiver. Got my point? Coming to the types of the channel, this medium we can classify into 2 types. One is low frequency one, another one is high frequency one. In low frequency one, what we are having? Transmission lines. What is the frequency of transmission lines? Tell me. 50 Hz. Next we are having twisted plastic cables. The bandwidth of twisted plastic cables is 200 kilo. It can be used for voice, video not possible because video itself is having in terms of megahertz. Next we are having in TV long back, flat ribbon cable. In long back, if you see the Doordarshan channel, we are using the flat ribbon cable. And coming to the high frequency, we are having coaxial cables. How the coaxial cable? There will be a main conductor covered by the insulator, secondary conductor covered by the jacket. In mostly in villages, One dish will be there. From there, for all homes, distribution will be there. What we are using is coaxial cable. Some 10-15 channels only possible. Now we are using fiber optics. How the fiber optics? Fiber optics is working on the principle of total internal reflection. Means it is having two parts, core and cladding. Core refractive index is slightly more when compared to cladding. So total internal reflection is going on. We can also send through atmosphere. Are you getting my point? In these cases, how the information flows? Information flows as a voltage and a current line communication. Here the information flows as a light energy. Here the information flows as a electromagnetic signal, EM energy. Are you getting? Like this is the types of the medium. In the previous I seen basic block diagram and what are the types of communication system based on the flow of information. Are you getting my point?